Good morning, good afternoon, good evening to everyone, wherever you may find yourself, and welcome back to my YouTube channel. Okay, before we start, for those who have not yet subscribed, kindly click on the subscribe button, for it doesn't bite. Today, I would like us to look at the binomial theorem of expansion. Binomial simply means two terms. How then do we expand two terms? We've seen expansions like a plus b all that squared, where the power of n is 2. What then can we do when the power of n is very large? Let's say a plus b to the power. What do we do when we have instead a plus b, for example, to the power 20 to expand? Right? It becomes so cumbersome. So to do expansions of such a type, we use what we call the binomial theorem, as a plus b all to the power n, which gives us sum from r equal to 0 to n combination r, a to the power n minus r, b to the power r. That is the binomial theorem of expansion that we can use. N here is the power, r is the term. So we are starting with the first term, r is equal to 0. And one thing you should note in this is that as the power, see this power is reducing, this power here is r is increasing. And the sum of the power of gives the power of the binomial. You notice that n minus r plus r gives us n. Okay, now that said, our main focus of today is to look at expansions of this nature when the power of n is negative. Take note, when the power of n is negative or a fraction, we use a different approach to expansion, because this binomial theorem works for when n is positive. So when the power of n is negative, we use this expansion 1 plus x to the power n is equal to 1 plus nx plus n into n minus 1 all that over 2 factorial, right, x squared plus n into n minus 1 into n minus 2 over 3 factorial x cubed plus it continues. You see, this is n followed by n into n minus 1. You see that the x cubed n into, you have 3 factors of n, x4, and so on. It continues. So that is what we use. If the power of n, if this power of n is a fraction, when we have expansion like this, where the power of n is a fraction or negative. Now we have this example with us. Expand 1 plus 2x all to the power negative 1. 1 plus 2x all to the power negative 1. Okay. Now, how do we proceed with the expansion? We have 1 plus 2x all to the power negative 1. It means our n is negative 1 in the first place. Now, if we are expanding it, they can specify, let's say till the term x squared. So it means here, always verify whether it's 1, because if it's not 1, we have to do some work. Okay, it is 1. N is negative 1. X here simply means this term. That's 2x plus negative 1. Let's expand till x squared. Negative 1 minus 1. X squared, that's 2x, all that squared, divided by 2 factorial plus 1. Now, when that is done, you have 1. Negative 1 times 2x, 2x. Here we have now negative 2 times negative 1, positive 2 divided by 2 is 1. Then 2x, all that square is 2 square x square. So plus 4x square plus n. We always put 3 suspension mark because we cannot be able to list all the terms. Okay, we'll continue with the second example. It says here, expand 1 minus 2x to the power half up to the term in x squared and state the range of values of x for which the expansion is valid. Alright, now 1 minus 2x to the power half. Okay, so we are using 1 plus nx. Our n is half, our x is negative half, negative 2x. Because 1 minus 2x can be written as 1 plus negative 2x to the power half. So we have 1 plus nx plus n into n minus 1, that is half into half minus 1, divided by 2 factorial, all that negative 2x squared. It is subtraction. Now when you simplify this, we're going to have 1 minus x, simplify here half minus 1 is negative half, okay, that's this one, half minus 1 negative half times negative half, negative 1 over 4, divided by 2 factorial, times 1 over 2, is negative 1 over 8, okay. Negative 2x all that squared, from law of indices is negative 2 squared, which is 4 times x squared. When this is simplified, we have 1 minus x minus half x squared. Okay, so that is what we do. Now we are asked to state the range of values of x for which the expansion is valid. The expansion is valid if this, let me highlight it well, for which obtain we find here. So it is valid if the absolute value of 2x is less than 1. Okay, the absolute value of this term after 1, the next term is less than 1. And for inequality, absolute value less than 1 means negative 1 less than 2x less than 1. I divide both sides here by 2, which will give me negative half less than x less than half. And that's half the fact that the one that the absolute value, that's the range of values. Alright, let's go to the next example. Okay, let's look at the third example here. Expand 5 plus 2x to the power negative 1 up to the term in x squared. Right, up to the term in x squared. Now, up to the first thing in this expansion I will need to look at is the fact that here the expansion 5 plus 2x to the power negative 1. We refer back to our expansion using 1 plus x to the power n. Means we have to do some manipulation on this. So this, what is inside, can be written as, you factor out the first step, 5. You factor out 5 here, becomes 1. Then here 2x over 5. If you are to try, see 5 times 1 will give us 5. 5 times 2x over 5 give us 2x. So what is inside here must be written in this form. Then now we have all this to the power negative 1, which is equal to 5 from the law of indices. ab to the power n is a to the power n, b to the power n. So this is 5 to the power negative 1 into 1 plus 2x over 5 to the power negative 1. Alright, so we are now concerned with this, and 5 to the power negative 1 is 1 over 5. Now 1 plus 2x over 5 means we are using now the expansion. Remember, we are using 1 plus x to the power n is 1 plus nx plus n into n minus 1 over 2 factorial x squared continuous, for which absolute value of x less than 1, that's the range. Now, so we have our 1 here, yes, n is negative 1, yeah, x here is this term, that's all of that term, 2x over 5, okay, plus n, negative 1, negative 1 minus 1, divided by 2 factorial, which is 2, then 2x to the power 2, okay, but let's say till the term in x squared, which when you arrange this, we have 1 over 5, we have 1 minus 3x over 5. Here, negative 1 minus 1, negative 2 times negative 1, positive 2 divided by 2, 1. Down here, from the law of indices, 2x to the power 2 is 4x squared, and all 5 to the power 2, 25. Okay. Now, so finally, the overall expansion is, now take 1 over 5 times 1 here, 1 over 5. 1 over 5 times negative 2x over 5 is negative 2x divided by 25. Now here 1 times 4, we have 4x squared. 5 times 25, 125, plus, as the answer to our expansion. Okay, that's it. So this gives everything. Okay, this gives you all the various forms. Now, the range of values for which it is, if it's instead the range of values of x for which it is valid, if you are asked to obtain the range for which the expansion is valid, okay, if it is for which the expansion is valid, it was arranged in this form. So we are going to use this since it has been put in that form. It is valid, so it will be valid if the absolute value of 2x over 5 is less than 1. Which implies here negative 1 less than 2x over 5 less than 1. We have negative 5 less than 2x less than 5. We divide both sides by 2. Okay. So which will give us, when we divide both sides by 2, gives us negative 5 over 2 less than x less than 5 over 2. Okay, thank you for going through. Thank you for following up. Please like, subscribe, share. Have a great time.